Have you ever stopped to really think about what's going on beneath the surface of our digital lives? All that, complex stuff, keeping your apps running, your data moving. It's pretty incredible, right? Well, today we're going to pull back the curtain a bit on a really critical piece of that tech puzzle. It's called vSphere. We're doing a deep dive into its core capabilities. And our source material for this, it's actually kind of unique. We're not just reading manuals. Nope. We've got a set of practice questions and their explanations from a technical exam, the 2V0-17.25 exam to be specific. Think of these less like test questions and more like little windows into real IT problems and how vSphere solves them. So our mission is basically to pull out the key knowledge from these scenarios, give you a shortcut to understanding what vSphere really does. Just for context, the exam itself is about 135 minutes, 60 questions, multiple choice, needs a 300 score, all in English. But that's just background.
Yeah, and what's great about using these questions is that they're essentially concise problems. They really make you think about how different vSphere features fit together. It helps understand not just what something does, but why it's important in a real setup,
Right.
what it means for the whole system.
Totally agree. Okay, let's dive in. First big topic, VM migration. So imagine you've got a running virtual machine, right? And you need to move it to a different physical server. But, and here's the catch, those servers don't share storage. How does vSphere handle that live without, shutting things down?
Right, that specific trick is called enhanced vMotion. What it does, essentially, is it combines two different technologies. You've got your standard vMotion that moves the live CPU and memory state, and then you have storage vMotion, which moves the actual disk files. Enhanced vMotion bundles them.
Yeah.
So the result is you can move a running VM between hosts, even if they have totally separate storage. It's huge for flexibility and avoiding downtime during maintenance or hardware issues.
That is seriously powerful, a real game changer compared to the old days.
Yeah.
Okay, let's switch gears a bit. Security, always important. Let's say your security policy dictates that nobody can directly SSH into your ESXi hosts. All admin access must go through the central vCenter server. How do you enforce that?
For that specific requirement, you'd use something called lockdown mode. When you flick that switch on an ESXi host, it basically blocks direct access methods like SSH. It forces all the administration through vCenter. This is really key for centralizing control and making sure your security policies are applied consistently everywhere. It definitely strengthens security posture by reducing the direct attack surface.
Makes sense. Central point of control.
Exactly. But, the one thing to remember is that vCenter itself then becomes even more critical. If you lose vCenter, managing those lockdown hosts gets tricky.
Good point. Something to factor into the overall design. Okay, so we've secured the hosts. What about the network connecting everything? Let's talk about a vSphere distributed switch, a VDS. You often have multiple physical network cards, uplinks, right? How do you combine those effectively to get more bandwidth and make sure things keep running if one connection fails?
Yeah, that's a common need. The standard for that, especially with a VDS, is LACP. That stands for Link Aggregation Control Protocol. LACP lets you bundle several physical NICs together so they act like one single logical connection. This gives you two big wins. More total bandwidth, obviously, but also redundancy. If one of the physical links in that bundle goes down, traffic just keeps flowing over the others.
So it's not just faster, it's more resilient too.
Precisely. It helps absorb those physical failures without impacting the VMs. It's pretty fundamental for high availability. I actually remember a case where LACP was set up on vSphere, but not quite right on the physical switch side. When a cable got pulled, oops, the redundancy wasn't actually there. Shows you need both sides configured correctly.
Oh yeah, classic. Gotcha. Need to check both ends. Good tip. All right, this next one always seems a bit like magic to me, getting the infrastructure to sort of manage itself. What's the feature in vSphere that automatically balances computing workloads across different hosts? And maybe even saves power by putting servers on standby.
You're talking about DRS Distributed Resource Scheduler. That's its main job. DRS looks at the resource usage across all the hosts in a cluster CPU, memory, and it automatically moves VMs around using vMotion to keep things balanced. This prevents hotspots and generally makes sure applications perform well. And yes, it also has that power management side, DPM, distributed power management. If the overall cluster load is low, DPM can consolidate VMs onto fewer hosts and put the idle ones into standby to save energy.
Okay, so it balances load and saves power, but it's important to know what it doesn't do, right?
Absolutely crucial distinction. DRS does not handle high availability like restarting VMs if a host fails. That's a different feature called vSphere HA, high availability. And DRS doesn't directly enforce resource guarantees, like saying this VM must get X amount of RAM. That's handled by resource allocation settings.
Right. So DRS optimizes, HA protects, and resource settings guarantee. They all work together.
Exactly. They're complementary pieces of the puzzle. Thinking DRS does everything is a common misunderstanding for newcomers.
Good clarification. Okay, let's shift from compute and network over to storage. Managing lots of different storage systems can get messy. Is there a vSphere feature that lets you group storage resources logically and apply policies, like saying, this VM needs gold tier storage, without worrying about the specific data store?
Yes, there is. That functionality is called Storage Policy-Based Management, or SPBM. SPBM essentially lets you define storage requirements as policies. Things like performance level, availability level, maybe specific features like replication. Then you just assign the policy to the VM. vSphere figures out which compatible data stores can meet that policy. It abstracts the underlying physical storage, making it way easier to manage and ensure VMs get the right storage service level.
So you manage based on needs, not specific hardware locations. That sounds much simpler.
It really simplifies things, especially at scale.
All right, digging a bit deeper into automation now, if you're using VMware's broader cloud management suite, the vRealize suite, which specific tool in there is the main engine for automating workflows? Something that can tie together vSphere tasks, maybe talk to external systems via APIs, run custom scripts?
Within the vRealize suite, a core automation component is definitely vRealize Orchestrator, often just called VRO. VRO is, well, it's the workflow engine. It's designed to let you build automated processes. These can automate complex vSphere tasks, sure, but also reach out to other systems, call their APIs, run scripts, basically orchestrate tasks across your whole environment.
So it's the glue for connecting different automation pieces together.
Pretty much, yeah. It enables that true end-to-end automation, which is so important for efficiency and consistency, especially in larger setups.
Okay, now for some really advanced stuff. High availability for storage itself across different physical sites. Let's talk vSAN stretched clusters. These are complex beasts designed for serious disaster avoidance. What are the absolute non-negotiable network requirements to make one of these work properly? And any common myths?
vSAN stretched clusters. Yeah, they have some very strict requirements. You absolutely cannot compromise on these. First, you must have a dedicated witness host. And this witness has to be at a third site, physically separate from the two main data sites. It's for quorum, basically prevents split brain.
Okay, third site for the witness. Check. What else?
Latency. The round-trip time, the RTT, between the two main data sites has to be incredibly low. We're talking less than 5 milliseconds.
Wow, 5 meters. That's tight. Why so low?
Because vSAN stretched clusters typically do synchronous writes. The write has to be acknowledged by both sites before it's considered complete. High latency kills performance there.
Got it. Synchronous writes demand low latency. Makes sense. Bandwidth.
Bandwidth, yes. The recommendation is a minimum of 10 gigabits per second, dedicated just for the vSAN traffic between the sites. You need enough pipe to handle all that replication data.
10 gig minimum. Okay, now what about the network type? Do you have to stretch layer 2 across the sites?
That's the common misconception. No, you do not need a stretched layer 2 network. While it can work, a routed layer 3 network between the sites is perfectly fine, and often preferred from a network design perspective. VAN traffic can be routed.
Okay, that's a really important clarification. Routed L3 is fine, doesn't have to be stretched L2. Good to know. All right, shifting back to performance, but at the VM level, let's say you have a really latency-sensitive application, a critical database, maybe a trading app. What networking tweaks or features inside vSphere can help squeeze out the best possible performance for that VM?
Okay, for those super sensitive VMs, there are a few key things. First, inside the VM's operating system, make sure you're using the VMX-Net3 virtual network adapter.
Why that specific one?
It's VMware's own high-performance pair-virtualized NIC. It offers much better throughput and lower CPU overhead compared to, say, the emulated E1000 adapter. It's designed for speed.
Right, VMX-Net3. What else?
Second, on your vSphere distributed switch, enable Network I/O Control, or NIOC. NIC lets you set shares, reservations, and limits for different types of traffic.
Yeah.
You can prioritize the traffic for your critical VM, ensuring it gets bandwidth and reducing potential latency caused by other, less important traffic.
So prioritize its traffic. Makes sense. Anything else?
Third, think about jumbo frames. This means increasing the maximum transmission unit, the MTU size, usually to 9,000 bytes, up from the standard 1,500. You need to configure this end-to-end on the VMs, NIC, the vSwitch, and the physical switches. For large data transfers, jumbo frames reduce the number of packets, which lowers CPU overhead and can improve throughput.
Okay, so VMX Net3 adapter, NIOC for prioritization, and jumbo frames potentially. What about just putting it on its own VLAN? Does that help latency?
Not directly, no. VLANs are for segmentation, for organizing traffic and security. They don't inherently reduce latency or improve performance. The other three are the direct performance levers.
Got it. VLANs for organization, not speed boosts. Excellent. Okay, infrastructure's built, it's optimized. Now we need to deploy VMs efficiently. Say you're using templates to create new VMs. How do you make sure each new VM automatically gets its own unique hostname and IP address so they don't clash?
The classic deployment headache. The vSphere solution for that is called a customization specification. When you deploy a VM from a template, you can apply one of these specifications. It contains all the settings needed to make the VM unique, the computer name, IP settings, domain join info, license keys, maybe run some scripts. It automates that whole personalization process, ensuring each VM comes online correctly configured and ready to go without conflicts. Saves a ton of manual effort and errors.
Customization specs, essential for automation. Right. Okay, last big topic. We talked about protecting VMs with HA, balancing them with DRS, but what about protecting the brain of the operation, the vCenter server appliance, the VCSA itself? What feature ensures that if your main VCSA fails, another one automatically takes over so you don't lose your management capabilities?
That specific protection for the VCSA itself comes from vCenter Server High Availability, or VCHA. VCHA sets up an active-passive witness configuration just for the vCenter appliance. If the active VCSA node goes down, the passive node automatically takes over its identity and services. The witness helps prevent split brain during failover. This ensures your vCenter management plane stays up and running, even if the primary appliance fails.
So VCHA is specifically for the vCenter appliance's availability.
Exactly. It's different from VCHA, which protects workload VMs, different from fault tolerance, which provides continuous availability for specific VMs, and different from DRS, which is for load balancing. VCHA is all about keeping vCenter itself running.
In this incredibly complex digital world we live in, where pretty much everything runs on some kind of virtual infrastructure, taking a moment to appreciate these specific functions, these hidden gears like LACP or SPBM or VCHA, it's not just about IT management or passing an exam. It's kind of about understanding the how behind the what. How does this stuff actually work to keep things running smoothly, keep data safe, prevent those outages we all hate? Maybe, just maybe, it inspires you to look a little closer next time, to ask, how does that work about the tech you use every single day?